Hi, I'm going to be talking today about chemical equilibrium and a misconception associated with it. You'll have to bear with me because I'm not great at drawing, but let's see what happens. Anyway, first off, what is chemical equilibrium? So according to my chemistry textbook, equilibrium is the rate at which the products formed from the reactants equals the rate at which reactants are formed by the products. Which is all well and good, but doesn't really help anyone that doesn't speak textbook. So here's a quick model. Say we have a simple reaction. A goes to B. So we have a beaker filled with A, and eventually it starts generating B. Now junior science would tell us that the reaction occurs until all A is gone. That is, it goes to completion. But equilibrium says they find a balance between both points. This doesn't mean the whole reaction stops. It just means that whenever A generates B, the opposite occurs, keeping a state of dynamic equilibrium. This equilibrium point can change due to a variety of factors such as pressure, temperature, and concentration of reactants versus products. So that's basically equilibrium in a nutshell. Anyway, so now for the misconception. Studies have found that many students, in one case up to 65.1% of students, believe that at equilibrium, the concentration of products equals the concentration of reactants. In our case, A equals B. This is not necessarily true, as whilst equilibrium does find a balance, it does not have to be equal. Not only this, but this balance will change due to the factors previously mentioned, which is stated in Le Chatelier's principle. There are a variety of explanations as to why students hold this belief, such as an oversimplification of this textbook definition to simply products equals reactants. Or other papers suggest that teaching junior students that reactions go to completion leaves them unable to adequately understand the incomplete nature of chemical equilibrium, or that misconceptions can be caused by an incomplete understanding of underlying ideas such as molecular movement and concentration gradients. Finally, some people simply believe that difficulty learning equilibrium comes from the abstract nature of the concept. Whatever the reason, it is a misconception that must be overcome in order to understand equilibrium, which is a foundational concept to further chemistry knowledge.